Question 1 from the Section 2 of the 2022 Higher Physics exam from SQA. The crossbar challenge is a football contest in which competitors try and hit the crossbar of a goal by kicking a football from the penalty spot. The horizontal distance between the penalty spot and the crossbar is 11 metres. One competitor kicks a football with an initial velocity of 17 metres per second at an angle of 24 degrees to horizontal. And you can see the diagram there, not drawn from scale. The crossbar is in fact the bar across the two goal posts. The football hits the crossbar and we have to ignore the effects of air resistance. Now for the first 2 marks we have to work out the horizontal components of the initial velocity of the football and the vertical component of the initial velocity of the football. Now to start off this problem, it's always best to draw a little axis like that and show your velocity vector. In this case it's 17 metres per second at an angle of 24 degrees. Now in all projectile problems we can split the motion up into two independent motions. We can split it up into horizontal and into vertical components. So that's what we do. So our horizontal component will line up like that and our vertical component will line up like that, and you've got a little right angled triangle in there which you can solve by using the sine, cos or tan. So the horizontal component is indeed 17 times cos 24. Always remember that because cos is on the ground, O, and that's how I always remember putting it into the diagram. But always rely on your trigonometry to get the correct answer. 17 times cos 24 for the horizontal component, therefore it's going to have a magnitude of 15.5 metres per second. What about the vertical component? The vertical component is always the sine of that, so it's going to be 17 times sine 24 degrees, and we work that out in our calculators, we get an answer of 6.9 metres per second. So there we have the horizontal component velocity and the vertical component velocity, and that's us gained our 2 marks. Question 1a continued. Part 2. It says, show that the time taken for the football to travel from the penalty spot to the crossbar is 0.71 seconds. Now, like in all these projectile problems, it's very wise of you to put down your list of all the characters involved, and remember you can split the motions up into horizontal and into vertical, and it's always best to draw a little table like this. So you have your vertical data, U, V, A, S and T. Remember, vertical data is the vertical component, and the horizontal data which is going across the way, the horizontal data, and those two are separate pieces of motion. So if you look at your situation here, we've been asked to find a horizontal fact here. So do we know the horizontal distance? Well, we do know it. It's the distance between this penalty spot and the goal line, so it's going to be 11 metres. So right away we can put in there 11 metres for this, so we plug in 11 metres and that distance is going to be 11 metres. What's going to be the horizontal velocity in this particular time? Well, we'll look again at our diagram, and our horizontal velocity, our initial horizontal velocity is going to be 15.5 metres per second, and that remains constant throughout the flight, 15.5 metres per second. And then we've got to multiply that by t. So if it's a simple case of working out t, therefore t is going to equal to 11 metres divided by the 15.5. And that's our answer. Will be in seconds, and if we do that with a calculator we get 0.709, which comes out to be, if we take it to two significant figures, 0.71 seconds, and that's what the examiner asked for, and that's our 2 marks, just concentrating on horizontal data. Question 1, part 3. The football is at a maximum height in its trajectory when it hits the crossbar, and for 3 marks we're asked to calculate the height h above the ground at which the football hits the crossbar. Now once again we go back to our little data table. There it is there with the vertical data and the horizontal data which we use to find the time taken to get to the crossbar. So now we put in all our vertical data. Now the initial vertical data, the initial vertical velocity is going to be 6.9. There's the initial vertical velocity there, and it's always a common mistake to put in 17 for this. No, we're dealing with the vertical data, that's why I put it into the blue arrow. The blue arrow is 6.9, so our initial vertical velocity is going to be 6.9, so we put that in there, 6.9. Now we've got to fill in the rest of the data vertically. What happens with the final velocity when we get to the maximum height? Well, we know from our understanding of projectiles that when the ball reaches the maximum height, its vertical velocity is going to become 0. And the acceleration acting on the ball all the way through the journey is minus 9.8. That's the acceleration due to the force of gravity. And what we've got to do is find this value here, S, which is really the displacement upwards, which is really the height of the ball. So there's our components. There's our data. We've got U, we've got V, we've got A and S, and we have to find an equation which all those fit into. So you look up your data sheet, and U, V, A and S, you're going to use the following equation. You're going to use V squared equals U squared plus 2AS. And we have to rearrange to get that S out of that. So bring this down here to the actual question itself, and we have V squared equals U squared plus 2AS. S stands for the height. We have to rearrange that to find what S is. So it's going to be V squared minus U squared. Put a bracket around that. And that's going to equal to 2AS. And to get the S on its own, we just divide by 2A. So V squared minus U squared. And that's all going to be divided by 2A. And that's going to give us the displacement upwards, which is going to be equal to the height. So all we have to do is plug in the numbers now then. So up here I'll plug in the numbers. S is going to equal to V squared minus U squared. Well, we know from our table V is going to equal to 0 and U is going to be 6.9. So it's going to be bracket 0, take away 6.9 squared. I'm going to divide that by 2 times the acceleration of gravity. Now be careful, the acceleration of gravity is acting downwards in our notation, so it's 2 times minus 9.8. And that's what we get for that answer. So if we do that in my calculator, we end up with a value of S to be 2.43 meters. It's a positive answer, which means of course the displacement is upwards, so therefore that's going to be the height of the crossbar. To two significant figures, we'd write down 2.4 meters. Question 1, part B. The next time the competitor tries a challenge, they kick the football at the same angle with an initial speed less than 70 meters per second. And we have to state for 2 marks whether the football hits the crossbar, or it passes under the crossbar, or passes over the crossbar. And we have to justify our answer. So you always must state one of those 3 statements up there and then justify your answer. Now, at the start of the problem, we had this situation here. We had the ball being kicked at 17 meters per second at an angle of 24 degrees to horizontal. And that provided us with these components, horizontal component and vertical component. Now if you kick the ball with a smaller velocity, which is this situation here, you can see quite clearly you're going to get a smaller vertical component and you're going to get a smaller horizontal component. Now what does that mean overall then? Well, it means the following statements. It means if you've got a smaller initial vertical velocity, that implies you're going to have a smaller maximum height. It's not going to go as high as the previous one. And that also implies that it's got less time to reach the maximum height. It's going to take a lesser time to reach the maximum height. Now, if it's taking a lesser time to reach the maximum height, that means the horizontal distance is going to be smaller as well underneath the maximum. So what we've got in this situation is that the ball passes under the crossbar. Now if you can't follow through that argument, it's best to go and see it live as it happens with a simulation, and to do that go to the PHET site and we can see what happens. Okay, here's the PHET site. We haven't got a footballer kicking a ball, but we have got a cannonball set at 25 degrees. We can't set it at 24 degrees. And we've got a speed which we can set at 17 meters per second, which is the speed the ball was kicked at. Now we kick the ball, we can see that the ball will take the parabola trajectory as shown. There's the maximum, just slightly under. There's a maximum there at the crossbar. So you can imagine a crossbar here. Now let's reduce the velocity to maybe say 14 meters per second and keep the angle the same, and let's see what happens. And our theory was correct. You can see the ball is not going to go to the same height as the 17 meters per second shot. It's going to be a less height it's going to reach, and it's also going to reach its maximum a lot less than it reached its maximum here. So if the goalpost was in this particular direction here, you can see very clearly that the ball will go under the crossbar, and that's all because you have decreased the vertical and horizontal components of the ball. So it's better to prepare your argument by looking through the PHET site, varying things and seeing what happens. So back to our question again, and our final answer is it passes under the crossbar for the reasons we've just stated.